Thank you for watching this video. This is Tom Robinson at the Bay Area Open Space Council, and I want to walk you through the methodology of the Conservation Lands Network. That's detailed in Chapter 3 and Appendix B of the Conservation Lands Network report that can be found at bayarealands.org. The Bay Area is a national biodiversity hotspot that is at risk of loss due to development. Indeed, if you ranked the nation's fastest growing metropolitan areas by the number of imperiled species by county, 8 of the top 17 counties are within the 10-county Bay Area. The Conservation Lands Network is a biodiversity prioritization created in 2011 to provide an answer to the question, what would it look like on a map if we wanted to save a healthy representation of the habitats and species found in the Bay Area so that the astounding biological diversity here has a chance to persist into the future? To answer that question, the ecologists and planners who developed the Conservation Lands Network employed a systematic approach that entailed 4 main components: selecting conservation targets, which are the species and habitats chosen to represent the biodiversity of the region; setting habitat conservation goals for those targets, such as protecting 90% of globally rare habitats found in the region; using GIS data and the Marksan analysis tool to map an efficient network of lands that meet those goals; and refining the network design based on its coverage of target species habitats. Perhaps the most important concept within the methodology of the Conservation Lands Network is the coarse filter, fine filter conservation planning approach to selecting and mapping conservation targets. The coarse filter, fine filter approach is common in conservation planning and begins with designing a network of land for conserving whole ecological communities, called the coarse filter, as opposed to a single species, followed by an assessment of the network design for its ability to cover species and embedded habitat elements, such as, say, ponds, that are either not predictably associated with particular ecological communities, or perhaps they range across many ecosystems. And these species may fall through the coarse filter analysis and require additional consideration, which is the fine filter pass. There's much more information about the coarse filter, fine filter approach online and in Drafting a Conservation Blueprint by Craig Groves. But the first step is selecting the ecological community coarse filter conservation targets and the species-based fine filter targets. For the CLN, these targets were set by teams of local biologists and experts formed around these various taxonomic groups. First, we'll take a look at the coarse filter targets. We'll cover the goals while we're at it, then move to the fine filter targets and goals before moving on to the mapping the network. Vegetation types were used as a proxy to define the region's ecological communities and serve as coarse filter targets. A combination of 3 vegetation maps were stitched together to create a wall-to-wall map. The stitch was followed by 2 modifications to improve the vegetation map for conservation purposes. The first was an overlay of serpentine geology to identify serpentine-dominated patches. The nutrient-poor serpentine soils lead to distinctive and in some cases endemic plant and animal communities on the ground that are typically too subtle to be captured in regionally scaled remote sensing-based vegetation maps. The overlay created new vegetation types such as serpentine grassland and serpentine scrub. The second was a stratification of the grassland class, which itself covered about 1 million acres, into 4 categories of grasslands based on maximum July temperatures. This captured the compositional differences between, say, coastal prairie found in the blue areas on this map and the semi-desert grasslands of the Central Valley shown in red. The result was a vegetation map consisting of 53 natural cover types. And here's a look at the final map and a close-up in Marin. Since the ultimate goal was to represent the different ecological communities as targets for the coarse filter analysis, the vegetation map was stratified by 29 biogeographic areas called landscape units. This created 573 ecological community targets based on vegetation. The reason to do this was so that as areas are being considered for inclusion into the Conservation Lands Network, habitat types that are deemed rare or particularly important in one part of the Bay Area aren't competing with the same habitat type in another area where it might be common. For example, blue oak woodlands are rare in western Sonoma County, but they are the most common oak woodland in the hills of northeastern Napa County. Thus, stratifying vegetation by landscape units localized the vegetation types, which made the 53 class vegetation map more representative of the ecological diversity of the region. And it allowed the vegetation focus team to assess vegetation types in a sub-regional context. The vegetation focus team mentioned before set the conservation goals for the different coarse filter conservation targets. The team ranked each of the 573 vegetation targets based on rarity. There were 3 ranks: globally rare, or highest priority in the locally rare vegetation, received a rank of 1. Rare vegetation within landscape units received rank of 2, and common natural vegetation types received a rank of 3. The team also decided on conservation goals based on those ranks, and it was determined that Conservation Lands Network should contain 90% of rank 1, 75% of rank 2, and 50% of rank 3. And here's a look at the rarity ranks in Marin, with serpentine leather oak chaparral as a rank 1, mixed montane chaparral as a rank 2, and montane hardwoods as a rank 3. Moving on to the fine filter targets and goals. All focus teams were involved with selecting fine filter targets for plant and animal species. Fine filter targets serve 2 purposes: as inputs into the network design, which I will cover in a moment, and to assess the network. There were many fine filter targets identified, too many to list here, so I'll refer you to chapters 5 through 8 of the Conservation Lands Network report at bayarealands.org for a list of the species. Of the many targets, 2 were deemed to have sufficient spatial data for applying goals and incorporating into the network design. The first were rare plants, which were ranked by the vegetation focus team and given goals of 90% for the top 15 priority target species and 75% of all remaining. The second were ponds, which were given goals of 75% of all ponds in larger landscape units and 50% of all ponds in smaller landscape units. For more information, including rationales of these decisions, see Chapter 4 of the Conservation Lands Network report. Streams were another fine filter target and were ranked by the Fish and Riparian Focus Team as either Priority 1 or Priority 2 based on their importance to native fish species, with the Priority 1 class reserved for coho salmon streams and inland steelhead streams. Now, all other mapped streams were designated as Priority 3. Since all streams and their associated riparian areas are so vital to biodiversity, the Fish and Riparian Focus Team decided to not apply a percentage goal. Given their linear nature, streams were not incorporated into the network design, so they're treated as an overlay and sort of a linear complement to the network. For more information on that decision, see Chapter 5. As an example of how the coarse filter fine filter approach works, 2 other fine filter targets, northern spotted owl and old growth redwood forests, were added after the coarse filter network was mapped, which again I'll cover in just a moment. Because after assessing the network for coverage of fine filter species, the vegetation and birds focus teams deemed that those targets were not sufficiently covered. Here's a look at the northern spotted owl map. Goals were set at 75% for all mapped owl occurrences and 90% of old-growth redwood forests. And for more information on these targets and goals, see Chapters 7 and 4, respectively. Next, I'll talk about mapping the Conservation Lands Network. MarkSan, a widely used GIS-based reserve design tool, was used to assemble the coarse filter network. MarkSan requires 3 inputs. First is the planning units, which are the consistently sized polygons to which MarkSan ties all input data and the analysis results. The input data included the 573 vegetation targets and their corresponding goals. For the CLN, a regular grid of 100 hectare or 247 acre hexagons was chosen to mirror the size of typical land conservation projects, and to preclude the appearance of targeting any specific parcel. Second is the suitability layer, which helps Marxan identify the areas best suited for vegetation target conservation. The suitability layer used three factors: population density, distance to paved roads, and density of parcels. The third input is made up of features that are, quote, locked in to the reserve network, meaning they're chosen no matter what. The project team chose to build the CLN from the existing protected lands. And to do this, Marxan was configured to lock in any planning unit with 10% or more of its area in protected land. Thus, the software preferentially chose hexagons adjacent to protected areas to create large blocks of conserved lands. Marxan uses an iterative algorithm to map the network. Marxan was run 20 times at 1 million iterations each. As it iterates, Marxan remembers which planning units, those hexagons, were chosen for the final design. Planning units that were selected 16 or more times are considered essential to achieving the conservation goals, and planning units that were selected 11 to 15 times are considered important to those goals. 2 refinements then followed. The first was removing converted lands from the network. Converted lands was made up of rural residential development, cultivated lands, and urban areas. And here's an illustration of that process on the Santa Rosa Plain in Sonoma County. The removal of converted lands created a third category: areas of conservation lands network that are fragmented. This was an important step because it preserved the part of the analysis unit that contained the targets for which it was chosen, while not including the parts where the habitat had been lost. Secondly, experts weighed in on areas that were not chosen for coarse filter or fine filter targets, but were deemed important for biodiversity nonetheless and should be considered further. These included areas that are known to function as habitat corridors or simply connected large blocks of conserved lands. These formed a fourth category: areas for further consideration. And these 4 categories form the Conservation Lands Network. The final report contains much more information, such as specific conservation goals for the different taxonomic targets, an assessment of the viability of conservation targets by looking at ecological impacts and threats like climate change, and recommended conservation actions. It also includes a chapter on measuring success. Also, the Council produced a progress report in 2014 that analyzed the progress toward the conservation goals 3 years after the original report. In it introduces 14 ways to measure success, and you can find the progress report at bayarealands.org. So to recap, the Conservation Lands Network is a reserve network design. Rarity is localized using landscape units. Teams of local experts chose the targets, the rankings, and the goals. Marxan was used to design the coarse filter network and establish the first 2 categories, the essential and the important. Converted lands were removed, distinguishing a third category of fragmented CLN. An expert input was used to refine the network and add areas missed, creating the 4th category, areas for further consideration. The result is a map of the Bay Area that communicates what land is already protected, what land is essential to protect for its biodiversity, what land is important, what land has been converted, and what land deserves further consideration. If the essential and important land is protected, we will meet our biodiversity goals of protecting 90% of globally rare habitats, 75% of locally rare, and 50% of common habitats, in an efficient network designed for connection and conservation suitability. There's much more about the Conservation Lands Network methodology in the final report that can be found at bayarealands.org. Thank you so much for watching.